After a while, you're going to find that very straightforward SQL statements, where you're just selecting a few pieces of data from a single table, well, they end up being a little limiting. If we've gone to all the trouble of defining multiple tables to store our data, we do that with the understanding that it will be possible to get it all back using the relationships that we've described. So I want to have one SQL query not to be limited to selecting from one table, but to be able to select from two different tables or even three or more. And the phrase we're going to use is to join our tables together. So in the example I'm going to go through, we have an employee table and a department table. And there's a one-to-many relationship between department and employee using the department ID column. Department ID is a foreign key in employee, it's a primary key in department. And it's just so we don't store redundant department details for each employee row. Now the question is, how would we start to join these together in SQL? Well, let's begin just by doing a fairly regular SQL statement. So I'm selecting a few columns, first name, last name, hire date, and department ID, just from the employee table. So we've seen this one before. No surprises there in the results that we would expect. So to start involving the other table, the magic word here is join. So after the employee table, I'm going to use the word join and then say department. So from employee, join department. This by itself isn't doing very much, but we're starting to add the necessary pieces bit by bit. If I say I want to join these two tables together, I can then start adding columns from the department table to the select clause. So after department ID, I'm going to say comma name, comma location that are both columns in my department table. But immediately we have a problem. If I'm now selecting from two different tables, it's really common that I'll have a name conflict. In this case, department ID is going to give us a problem here because department ID exists as a column in the employee table and as a column in the department table. So the SQL query would be very confused. Which one am I talking about? And in this case, what I could do is just prefix that with the name of the table. It wouldn't actually really matter which one we picked, but we need to be explicit so that SQL doesn't get confused. And if I wanted my SQL statement here to be very explicit, I could do this for every column. So select employee.firstname, employee.lastname, employee.hiredate, department.name, department.location, and so on. But I still do have an issue. I still couldn't run this query because I need to describe exactly how these tables are to be joined together. And the way that we do that is to use the word on, and we'll use that in conjunction with join. So it's employee join department on, and I name the columns in each table and how they link together. In this case, it is department ID, employee.department ID equal to department.department ID. We've now described how the join happens. And if I run that statement, we'll get the results back, which is joining these two tables together. And one important idea here is in the kind of join that we're doing right now, it's only going to bring back rows where there is a match between the two tables. So if you notice in the actual employee table at the top, the third row is Alice Bailey. Well, Alice has a department ID column value of null. She's not linking to department. So what that means is when we do the join, we will not get a row coming back for Alice Bailey because it has to have a match. And that's because what we're doing here is called an inner join. So I'm using this join keyword here, and if I was to be good about this, and I usually would be, I should use the words inner join rather than join, even though that is the default kind of join, is an inner join, meaning only bring back the rows where there is a match in both tables. So we'll neither see the row like Alice Bailey because she has a department ID of null, but on the other hand, nor will we see any of the rows from the department table that don't have matching employees. In this simple example here, I don't have anybody with a department ID of 1, so I'm never seeing the row that says production CA with a budget code of A4. But sometimes you might want to start involving these other rows that don't exactly match. And that would be by creating something called an outer join. An outer join means we're going to pick one of the tables and say, this one takes precedence. We want to see all of the rows returned from a particular table and still show the matching data where possible. Now that might sound a little weird, so let me demonstrate what the difference would be. So instead of using the inner join keywords, I'm going to use outer join, but I can't just write outer join. I have to be explicit. With an outer join, you're typically saying one of these tables takes precedence over the other. We are interested in where they match, but we still want to get the results where they don't. So I would typically use the word left or right, a left outer join or a right outer join. Now the left and right here simply means, is it the table on the left-hand side of the word join, which for us is employee, or is it the one on the right-hand side of the word join, which would be department? So in this one, I'm going to do a left outer join, and it's going to look to the left of the word join and see employee, and then say that employee will take precedence. Now we get back very similar results, but we are getting back a row for Alice Bailey. Even though Alice Bailey doesn't link to a row in department, we're getting that row back. We're just getting null values because there's nothing we could put there. Conversely, what I could do instead of a left outer join, if I just change that left outer join to right outer join, we now put the focus on the department table. And we say, we want everything that matches, but we want everything from that department table. And in this case, we would have rows coming back for the production department, which doesn't have any associated employees. We'd have rows coming back for the marketing department, which doesn't have any associated employees, and we would still write out the ones that match. And that's the right outer join. There is even a full outer join, which does both. I'm a little pressed for space here, so I won't show that, but as you might imagine, it says to include all rows from both tables in the results, matching them wherever possible, but returning rows with null values when there's no match between them. Now, as you start to read more and more SQL, you'll probably come across a couple of different ways that joins can be written, but this is the recommended ANSI SQL standard way of doing it.